In the last hyperbola video, I didn't get a chance to do some concrete examples, so I'll do that right now. So let's say I had the hyperbola y squared over 4 minus x squared over, I don't know, let me think of a good number. Let's say x squared over 9 is equal to 1. So the first thing to figure out about this hyperbola is what are its asymptotes. And once again, I always forget the formulas, and I just try to solve for y and see what happens when x approaches positive or negative infinity. So if you solve for y, you can add x squared over 9 to both sides, and you get y squared over 4 is equal to x squared over 9 plus 1. Now I can multiply 4 times both sides, and you get y squared is equal to 4 over 9 times x squared plus 4. Right? Distribute the 4. Take the positive and negative square root of both sides. Y is equal to the plus or minus square root of 4 over 9x squared plus 4. And you can't really simplify this anymore, but we can think about what does this approach as x approaches positive or negative infinity. So as x approaches plus or minus infinity, what does this roughly equal? What does this approximate? What does the graph get a lot closer to? Well, then y is approximately equal to just the square root of this term, because this becomes super huge. And relative to this term, this starts to matter less and less and less. And that's why we get closer and closer to the asymptotes. Because when this number is like a trillion or a Google, then this number is almost insignificant. When you take the square root, you're pretty much taking the square root of this, and you'll just be a little bit above the graph because you have this extra plus 4 there. So as you approach positive or negative infinity, this equation is approximately equal to the plus or minus square root of 4 over 9 x squared. And so that is, so y would be approximately equal to the plus or minus. We can take the square root of this. Plus or minus square root of 4/9 is 2 over 3, right? Square root of 4 over square root of 9 times x. So these are the asymptotes. There's two lines here. There's y is equal to 2/3 x, and then there's y is equal to minus 2/3 x. So let's draw those two lines. Let me draw my axes. So let's make that my y-axis. Let's make that the x-axis. Let me switch some colors just to make things interesting. So let me draw the first one. See, y is equal to 2/3 x. So you rise 2 for every 3 that you run. So let me draw that. So if this is 1, 2, 3, 1, 2. So that would be a point on the line. And let me draw the line now. It should go through the origin. Oh, no, that's not it. Let me draw it like this. This way I can make sure it goes to the origin. So it's going to go through like that. And then I could go from here and then go like that. So that's one asymptote. And the other asymptote is y is going to be equal to minus 2/3 x, right? Because it's plus or minus 2/3 x. So minus 2/3 x, you go down 2 for every 3 that you go out. So that point will show up. Let's see if I do 1, 2. So you go down 2 for every 3 that you go out. So it'll go there. So if I draw that asymptote, it'll look something like, go there, go out there, and then go from here, go out there. And we've drawn our asymptotes. Now the question is it going to open up to the left and the right, or up and down? There's two ways we can think about it. And I'll do it the way that might be more intuitive for you is, what happens when x is equal to 0? Well, when x is equal to 0, this disappears, and we're just left with, I'll do it here, y squared over 4 is equal to 1, or y squared is equal to 4, or y is equal to plus or minus 2. So we know that the point 0, the points 0 plus or minus 2 is on this graph. So x can be equal to 0. So 0 plus or minus 2. So 0 plus 2 is this point right here. And 0 minus 2 is this point right there. So that by itself actually is enough of a clue to know that it opens down here and up here, because a hyperbola will never cross the asymptotes. It's not like it can go out here and cross this asymptote. So we already know that the graph of this parabola, and you can try other points if you want just to verify it, it's going to look something like this. It's going to go and then get, nope, I want to make it so it never touches. So it's going to get really close. Oh no, I touched it. It's going to get really close but never touch. And then on this side, it's going to get really close but never touch. And I don't want to touch it. And then on the top side, it's going to do the same thing. It's going to get really close. And as you approach infinity, it's never going to touch it. And as you get really close, it's going to get infinitely close but never touch it. So that's what this parabola, this hyperbola, is going to look like. And I did it by just trying to see if x could be equal to 0. And I encourage you to try what happens when y equals 0. And you'll get no solution. And that makes sense because this hyperbola never crosses y equals 0, right? It never crosses the x-axis. And this should also be intuitive because if we saw here when we did this approximation as x approaches positive or negative infinity, we saw that we always did have this plus 4 sitting here. But we said, oh, well, as x gets super large or super negative, this starts to matter less and less. But we will always be slightly larger than this number, right? Especially in the positive quadrant, right? We're always going to be, so in the positive quadrant, we're always going to be slightly larger than the asymptote. And when we take the positive square root, I guess is the best way to say it. When we take the positive square root, we'll always be larger than either of the asymptotes. And likewise, when you take the negative square root, you're always going to be a little bit smaller than either of the asymptotes, because this number is going to be a little bit bigger than this number. And then when you take the negative square root, you're going to be a little bit smaller. And that's why we're a little bit below. I don't know which one's more intuitive for you. Maybe just trying it when x is equal to 0 and when y equals 0 and see what points you get. And you say, oh, then I'm in the kind of a vertical hyperbola as opposed to a horizontal one. So let's see if I have time for. I'll leave that video right there, and then I'll do another video where I actually shift the hyperbola. And shifting it is actually no different than shifting an ellipse or a circle. You just have, y minus something squared and x plus something or x minus something squared, and that just tells you where you shift the origin. This hyperbola, of course, is just centered at the origin. Anyway, see you in the next video.